Hi guys, Dr. Kruse. We're going to do some probabilities here with the word or. So the probability of the first event happening or the second event. So in this case here, what's the probability of choosing one card from a standard deck of cards and getting either a red card or a black card? So let's say, you're playing a game and either one of those is a winner. If you draw a card, a single card, you're choosing one card. If you draw a card and it's either red or black, you win. Let's calculate the probability that you will win. So the first thing we do is we write out what we're looking for. We're looking for the probability of a red card or a black card. Next, we write the rule that we're going to use. For this, we use the addition rule. It's the probability of drawing a red card, and we want to add to that the probability of drawing a black card. And then sometimes we count things twice. So we want to subtract the probability that we accidentally counted somebody twice. And if both of these could happen at the same time, then we're going to end up counting it twice. You'll see in a couple examples from now how this works. So let's work through this a piece at a time. Let's calculate the probability of drawing a red card out of a deck of cards. I have a graphic up here of a deck of cards. Clubs are black and they are ace through king. That's 13 cards. Spades are also black, ace through 13. I don't know why I said 13. Ace through king, that's 13 cards. Hearts are red, that's ace through king, 13 cards. And diamonds are red, ace through king, that's another 13 cards, for a total of 52 cards in a deck of cards. So when you're doing probabilities with a deck of cards, your probabilities are always going to be out of 52. Out of 52. There's 52 total cards. All right, so for the probability of drawing a red card, I've just colored in all my red cards. Hearts and diamonds are both red. I colored in 13 hearts and 13 diamonds, so that's 26 cards are winners. The probability of pulling a red card is 26 out of 52. So 26 winners out of 52 possible cards. All right, now let's calculate the odds of pulling a black card. All right, so I've colored the black cards, the clubs and the spades. I've colored them all yellow. There's 13 clubs and 13 spades. That's 26 chances of winning by pulling a black card. So we have plus 26 out of 52 again. All right, now we just need to check before we walk away and grab our calculator. Was there any probability of pulling one card that is both red and black? All right, this is impossible. You can't pull a card that's both red and black. They're either red or they're black. So I'm going to say there is no chance of this happening. You'll see how this works later. This takes out cards that we accidentally count twice. Now, we didn't count anything twice in this example. We counted all the red cards, we counted all the black cards. Nothing got counted twice, so I don't have to subtract any extra counts out. So we grab our calculator, add these up, change it to a decimal. Well, 26 and 26, that's all 52 cards, all right? So if this is a game and somebody says, hey, you win a prize, if you draw one card and it's either red or black, you win a prize. Well, you're going to win a prize. That's a 100% chance. We've colored every single card. Every one of these cards that you could possibly draw is a winner. So answer it as a decimal. That's 1.0000. Bump the decimal 2 to the right. That's a 100% chance of winning this one. So the probability of drawing one card and that it's red or black is 100%. All right, look at this next one. What's the probability of drawing one card? And let's say you win if you draw either a heart or a diamond. Let's calculate your odds of winning. All right, so I have shaded all the hearts in yellow. There's 13 of them. And I've shaded the diamonds in orange here, and there's 13 of those. So let's go through our probabilities here. The probability of heart or diamonds, that's what they want. I'm going to use the addition rule, so plus probability of hearts plus the probability of diamonds minus anybody we accidentally counted twice. All right, probability of hearts, there's 13 of them out of 52. All right, plus the probability of diamonds, there's 13 of them out of 52. And then minus, we just got to check and ask ourselves, is there a possibility of drawing one card that is both a heart and a diamond? No, that's impossible. If you draw a red card, it's either going to be a heart or a diamond. There's no way that one card can be both a heart and a diamond. So that's going to be another 0 again. And so we wind up at roughly exactly a 50% chance of winning this game. So if somebody walks up to you and says, hey, if I let you draw one card and you get either a heart or a diamond, you win a prize, you have a 50% chance of winning that prize. All right? Kind of makes sense because half of the cards are hearts or diamonds. So half is 50%. You have a 50-50 chance of winning. All right, let's try this on. What's the probability of choosing one card and getting either a king or a club? All right, you're playing a game. Somebody says, hey, draw a card. If it's a king or a club, you win a prize. Let's calculate the probability that you win this prize. All right, well, let's mark our kings first. Okay, so there's our kings. There's 4 of them out of a total of 52 cards. All right, so there's 4 chances to win by drawing a king. Now, if I draw a club, I also win. So let's mark the probability of drawing a club. So I marked my clubs in orange here. There's 13 of them. So there's 13 chances to win by drawing a club. But wait a minute. See this guy right here? We counted him twice. We counted him as a king. He's one of our 4. And then we counted him as a club. He's one of our 13. We counted this guy twice. Okay, that's no good. We can't count him twice because we win if we draw a club or a king. Let's just count those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's 16 cards that will win. All right? There's 16 cards out of 52 that will win. But look what happened here. 4 plus 13, we're up to 17 cards that'll win. That's not correct because we counted this guy twice. All right? So we need to take out that extra time that we counted him. All right. So we're going to take out one of those. All right. We counted this guy twice. We counted him once with the kings and once with the clubs. That's one too many. We double counted him. So let's take out the extra one. So it's the probability of a king. There's 4 of them. Probability of a club. There's 13 of them. But one of those guys we counted twice, so we take out the extra count. And that gets us back to 16 winning cards. 4 cards win, 13 cards win. That's 17. That's too many. Oh yeah, we counted that guy twice. So that gets us down to 16 cards that win. There's 13, 14, 15, 16 cards that win. Right, so we wound up at 0.3077. That rounds up to about 31%. So the chance of winning this game, if we get a prize for drawing either a king or a club, we have about a 31% chance of doing that. Not a great percentage. All right, what about this one? Let's change it just a little bit. Draw one card. What's the chance of getting a jack or a red card? So you get a prize if you draw a jack or a red card, either one. If you draw a jack, you get a prize. If you draw a red card, you get a prize. Let's calculate this probability. All right, so the question says, what's the probability of getting a jack or a red? That's the probability of jack. Let's color that in. All right, there's 4 jacks out of 52 cards. So there's 4 winners out of 52. And now what's the odds of winning with a red card? Well, the hearts and diamonds are both red, so let's color in those bottom 2 rows. And it looks like I have 13 hearts and 13 diamonds, so I have 26 chances to win by drawing a red card. So I got 4 jacks that'll win, and I got 26 red cards that'll win. It looks like I got 30 cards that'll win. Let's go up and count real quick. I got 13 diamonds, 13 hearts, that's 26 cards, 27, 28. There's only 28 cards that will win. Any of the hearts and diamonds, that's 13 each, that's 26, plus these 2 jacks, 27, 28. There's only 28 cards that'll win for me. I've already got this up to 30. So what's going on? What's going on is I counted these 2 jacks twice. All right, I counted them with the jacks, and then I counted them again with the red cards. So I counted this one twice, and I counted that one twice. I got 2 extras that I have to subtract back out. All right, so I subtract out the 2 extras right here. These 2 jacks, they were counted twice. So I got an extra count there and an extra count there. I got to subtract out the 2 that I counted twice. And I have about a 54% chance of winning this bet. Now you guys don't need to use this chart every time. I mean, if you understand how a deck of cards works, you can just talk yourself through this. You can say, hey, are there any jacks that are red? Are there any cards that are both jack and red? So we're talking about red jacks. Okay, red jacks. Oh, that's the jack of hearts and the jack of diamonds. So you can figure out this number without the table if you want to. It's pretty easy. You're just looking for cards that are both red and jack. There's 2 of them. You counted them twice, so you subtract it out. Same thing up here. You're looking for any card that might be a king and a club. Well, there's one of those, the king of clubs. So that one you have to subtract out the extra count because you counted it twice. All right, I want to show you a couple more here that are not deck of cards problems. So a large department store has 500 employees total. There are 350 females. Okay, so out of these 500, 350 are females. And 200 of these females, 200 are 24 years old or younger. Let's just call those young, all right? So 200 of these 350 females are young. There are 75 males, 24 years old or younger. Let's call them young. So there are 75 young males. If an employee is selected for promotion, let's just imagine an employee being picked out of a hat for a promotion, which is not a good way to do a promotion, but it'll help us with the probability. So if there's 500 names in the hat, and we reach in there and we pick an employee out for a promotion, what's the probability that the employee that gets picked will be, let's say, old, over 24, or female? All right, let's figure out the chances that they're over 24 or female. All right, you might be able to do this without a picture, but I can't. I have to draw a picture, and I usually use a tree diagram on these type problems. So I start with my total, and they told us I have a total of 500 employees. So total with a note about how many. And then usually it splits, and then sometimes it splits again. All right, so let's walk through those splits on our tree. It says there are 350 females. Okay, I'm going to stop there. They must have split it into females versus males. All right, so female versus male. They said there's 350 females, so they gave us this number. They didn't tell us how many males there are, but we can find out. We'll just subtract the 350 from the 500. That means there's 150 males. All right, so they're not going to give you all the information. They'll give you some of the numbers, and you got to figure out the rest. Okay, there are 350 females. We've noted that. Now, 200 of these females are 24 years old or younger. Let's call those young females. You know, we get hung up on the over 24, under 24 thing. It gets a little confusing. Let's call these the young people, under 24 years old. So 200 of the females are young. So they must have split again into young versus old. Okay. So I've split females into young and old, and I've split males into young and old. It says 200 of the females are young. So young. 200 of these 350 females are young, which means the rest of the females are old. By old, we just mean over 24. So out of 350, 200 are young. If you subtract, that means 150 are old or over 24. Now we need some information about the men. It says there are 75 males, 24 and younger. So these are young males. There's 75 of them. Young males, 75 of them. All right, if there's 150 males and 75 are young, that means just subtract. That means 75 are old. Okay, now I'll show our work over here with our 4 lines of work. But looking at this tree diagram, we can figure out this probability. If an employee is just pulled out of a hat for a promotion, let's find the probability the employee is over 24. Remember we called that old? So it could be the old females, 150 there. Could be the old males, those 75 right there. All right, so I circle them. That adds up to 225. So there's 225 winners. If you draw an old female or an old male, that's a winner. And then they could also be female. They can be old or female. So if it's a female, it also wins. Well, there's 350 females, so either young or old is going to be a winner. So I circled them in red just to be different. All right, let's go through it again. Probability they're old. Well, that could be the old females, 150. Could be the old males, 75. Or female. Well, that could be the young females, 200. Could be the old females, 150. Now note that I counted these guys twice. We can't do that, all right? So the winning card, the winning draw is young females. There's 200 of them. Or old females, 150. Or old males, 75. If I add those three up, out of 500, that's my probability. I just got to remember, don't count this twice. All right? So let's go ahead and write down our formula and just work it out with our 4 lines of work. All right, so what we're looking for is the probability they're old or female, that random draw, which is the probability of old minus the probability of female minus anybody we accidentally counted twice, minus anybody who is both old and a female. All right. Probability that I reach into the hat, there's 500 names in the hat. Probability that I reach into the hat and I pull out an old person. Well, there's 150 old females and 75 old males. That's 225 old people out of 500. Okay. Plus the probability that I reach into the hat, there's 500 names in the hat, plus the probability I reach into the hat and I pull out a female's name. All right, well, there's 350 females. 200 young and 150 old for a total of 350. So there's 350 females out of 500. All right. And did I count anybody twice? Were there any old females? Females, old. Yeah, there were 150, and I counted them twice. There's 150 people who fit into both of these categories. So they got counted with the old people, but they also got counted with the females. I can only count them once, so I need to take one of those away. I'm going to take 150 away. All right, so we wind up at about an 85% chance of winning. So if this was a game and there was 500 names in the hat, and you won the game if you picked out somebody who was old or female, what's your chance of winning? You have a 85% chance of winning. You have an 85% chance of picking out somebody who is either over 24 or female. And let's just double check how the numbers add up here. I need a 200 plus 150, that's 350, plus 75, that's 425 names that could win. All right, don't count this twice. 425 could win. 225 and 350, that's 575. Take away 150, that's 425. Yeah, that checks out. There's 425 names that could win. All right, this will be the last one for today. 2 dice are rolled. All right, now remember on a die, there's the numbers 1 through 6, and we're rolling 2 of them. Find the probability of rolling doubles. Let's say you win if you get doubles, or a sum of 4 or 6. I'm actually going to combine these 2 together, and I'm going to say either sum will work. Okay, so I'm going to look at it like this. If you roll doubles, you win, or if you roll this sum, you win. And the sum can either add up to 4 or 6, it doesn't matter. So rolling doubles wins, rolling sums wins. Let's calculate your probabilities of winning. Hint, list the sample space first. Sample space is all the possible rolls you could do with 2 dice. And to come up with that, what I do is I pretend the first dice gets stuck on 1. And I say, well, then it could be 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. That's all the possibilities if the first die is stuck on 1. And then I say, okay, well, maybe the first die is stuck on 2. 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, and so on until I've created all possible rolls that I could do with 2 dice. So this is my sample space. These are all the possible outcomes if you roll 2 dice. All right, So now let's work through our probabilities here. I want the probability of doubles or this sum. All right, so I win if I roll doubles or I roll the proper sum. Probability of rolling doubles plus the probability of rolling the correct sum minus anybody that accidentally counted twice, minus any doubles that are also the correct sum. Well, we're going to have to go through our sample space and figure this out. Let's start with doubles. Let's figure out the probability of rolling doubles. All right, so I've highlighted my doubles, 1, 1, 2, 2, and so on. Little downward diagonal there. Looks like there's 6 of them out of, let's see, that's a 6 by 6 matrix. Anytime you have rows and columns of numbers, these are rows, these are columns, that's a matrix. So downward diagonal, I got 6 out of 6 by 6 is 36 possible outcomes. So there's 6 rolls that are winners, all right? Now, if I roll the appropriate sum, I also win. So any 2 dice that add up to 4 or 6 are also winners. All right, so I marked in orange what adds up to 4 is 1 plus 3, 2 plus 2, 3 plus 1. Can't see those very good. These guys add up to 6, 1 plus 5, 2 plus 4, 3 plus 3, and so on. So these upward diagonals add up to 6. So it looks like there's 1, 2, 3, 4, 5, 6, 7, 8 winners that have the appropriate sum. All right, so it looks like I have, let's see, 6 and 8. It looks like I have 14 different rolls that will win. Well, let's count them real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wait a minute. There's only 12 rolls that will win, but over here I've got 14. What happened? Why do I have 2 extra? These guys right here got counted twice. Okay, this is the kind of thing you got to watch out for. 2, 2, and 3, 3. We counted them once with the doubles right here. They're part of my 6. And then we counted them again with the sums. They're part of my 8. I counted them here and I counted them here. I counted them too many times. All right, so I got to take out the extras. I counted this one twice. That's 1 extra. I counted that one twice. That's 1 extra. So I got 2 extras I need to take out. All right, so we wind up having about a 33% chance of winning. Actually, 0.3 repeating is exactly 1/3. So out of every 3 times you roll, 1 time you will get doubles or a sum. 1 time you will win out of 3. That's not very good. 33% is not very good. All right, you guys don't necessarily have to make a sample space. Some of you guys can figure it out without doing this, but it's certainly a lot easier to see if you have a visual like this. All right, so walk through it one more time. How many doubles did I have? I had 6 doubles. 1, 1, 2, 2, 3, 3, etc. out of 36 possible. How many sums did I have? I had 8 pairs that added up to 4 or 6 out of 36. Now, did this happen at the same time? Were there any doubles that also added up to 4 or 6? Yeah. 2 and 2 are doubles that add up to 4, and 3 and 3 are doubles that add up to 6. So there were 2 rolls that were in both categories. They got counted here and here. So I got to take out the extras. Got to take out the 2 extra. All right, that's all I got for today, guys.